All right. Let me send in. Let me send in a notification that we are live. Let me send in. Let me send in a notification that we are live. Okay, it's pretty. That's good. Oh, today was a rough day. Today was a long day, y'all. Today was a long day. Welcome back to the stream. We're here learning. Today we'll be hitting chapter 7 on the Linux basics for hackers. Okay, so before we hit chapter 7, we need to go back to chapter 6 for a little bit. So there's something that we need to, figure out. We're going to do something cool and nice. So we're going to research about that for now, and then we will we are live. All right, the post is up. They started a little bit late. It's at 7, but that's all right. That's cool. Let me lower down the music a little bit. Seems like it's a little bit high right now. All right, I think that should be good. Let's listen to it once more again to know that we are good for sure. Let's listen to it once more. All right, I think that should be good. Let's listen to it once more again to know that we are good for sure. Let's listen to it once more. And that's just gonna be looping all over again. Let's listen to it once more again to know that we are good for sure. Let's listen to it once more. All right, I think that should be good.
Yeah.
Once more. Let's get on with this. You know what I'm saying? All right. So what we wanted to do last chapter was this part. Was a script called iYeso context and important with the text editor and then scheduled to run next Wednesday at 1 a.m. This is what we need to do, right? I guess what we can to schedule it to run. My scanning with the text editor and then schedule to okay, maybe because we created a program that displays hello world. Maybe we should have changed it to output. Nah, I think that's C++. I think that's a C++ thing. Okay, so we had this Python app, not Python app, but just this little Python thing right there, right? That was a script. That's a script that we wanted to run, to just pop up, but it's not doing that. So we're going to try to kind of like create it a little bit. So we're gonna work on it again. And let's see if it's gonna do a much better job this time. Okay, so what we can do is go into Nano, and then was my screening. This time we're not going to just my screening that text, right? We're just going to print hi. Okay, write out my screening that text. Okay. So now if we can do cat my screening that text, it's gonna print hi. Okay, so maybe now we can like have like a timer. We can have like a timer that prints that out. so the script was, I mean, the command was at, let's say, 1 minute. My screening that text syntax last token screening minutes. Okay, maybe minute at 1 minute. Okay, let's try the at now plus 1 minute. Hold up, that's the syntax, is it not? That was the syntax. At 7, well, at now plus 5 days plus 20 minutes. At now plus, I mean, I know 1 minute is like, a minute. 1 minute. Syntax error. Last token syn m. Okay. At now plus 20. Okay, sorry, minutes plus, let's do plus 2 minutes. Okay, let's just do the time. Okay, let's do a clock. What's the time right now? We can do date. Okay, it's 7:43. So you can do at now. Not at now, but at 7:44 p.m., right? Okay, p.m. At 7:44 p.m. Why was it? My screening that text. Or do I have to put like or do I have to, say like, no, and now my, oh, okay. So this is what we have to do, right? We have to put the time. So at now plus 1 minute, right? Like that, create that. All right, and then when we have this at, and then that's when we can, like, what is it gonna be, nano open, or is just, sure, I don't know where my screening is at. Okay, let's just do my screening that txt, and then I believe you do Control C or Control D to get out of it. Okay, job 5 at Monday 19:45. Okay, let me look for where is my screening that txt, because I do not know where it is. What do you mean it's not found? It wasn't found, like, really? What do you mean? My screening.txt. Well, it's not a. How come I can open it? So, okay, locate my screening.txt. Seems like it's here. Okay, it's here. Okay, so what we can do? Okay, where am I? Oh, pwd. Okay, we're /user/home. Okay, so we can do /home/ okay. So, and now we can do now plus 1 minute. We do at we do slash home slash user one slash my screening dot txt. That's done. And then that. Okay. So now end of line, end of text, I guess. So now we wait until at 1:47. Now I wonder, really, like just open it or do something else? Let's look at the processes. Let's look at what's happening here in the task manager. Let's see if something will happen or if a process will be um created. Task manager. Why am I looking over here when I already have tab over here already showing? Okay, so user one. Oh shoot, it went away. User one top. Okay, that's what we're using. Using one top. Say open through XROG wrapper, thread, CPU. No, I believe it's past that time. It's already 48. So where did it go? So what did it do? That's what I do not understand. So, oh, do I have to give you like a script? Like, and now, okay, I will do cat my screening that txt. Is that what it needs to happen? What if I do this? Right? And then I do home slash user one slash my screening that txt and then control D. Control D. All right. It sends that up. Okay, now let's just sit there and wait. I don't know if they will all do it at the same time though. If they will all do it at the same time though. So I'm here waiting. Wrapper, 2.0. Oh, we got something in the terminal, and then it went away. Wait. We had some, yeah, exactly at 1:49, at 7:49. We had something happen in the terminal, but it did nothing. Nothing appeared. Nothing appeared. It did show that there were some processes or something happened in the terminal, but I don't know if I have to close out the terminal and then it will open up the terminal by itself. Okay, maybe let's try that. And then okay, so slash home slash user one slash my screening dot txt. Okay, and online. All right, we're going to end that. So we're going to close out the terminal, though I like this one. All right, now we're just going to wait. Open as root, open new window, arrange desktop icons, desktop settings, applications. Oh, that's easy that you can pretty easily just impact it. Open it right here. Any second now. Sunday. Should it not be opening up any second? Well, it seems like there's a spike. There's another spike again. I don't know if that spike came from me opening this up. Okay. Well, that's something that we can learn later on, but it's something that's really useful. You kind of like tell at this time do this, at this time do that. That's it. That's a good thing to know how to do it. Anyways, let's start with chapter 7. Let's just do some quick introduction reading, and then we're gonna start with the, if they have exercises, we're gonna start doing the exercises and everything else. All right, chapter 7. All right, to get the most from your Linux hacking system, you need to understand environment variables and be adept at managing them for optimal performance, convenience, and even stealth. Among the areas that Linux newcomers find problematic, however, managing the user environment variables might be the most difficult to master. Technically, there are two types of variables: shell and environment. Environment variables are process-wide variables built into your system and interface that control the way your system looks, acts, and feels to the user, and they are inherited by any child shells or processes. Shell variables, on the other hand, are typically listed in lowercase and are only valid in the shell they are setting. To avoid over explanation, I just cover some of the most basic and useful skills for environments and shell variables in this chapter. Okay. Variables are simply strings in key value pairs. Generally, each pair will look like key equals value. In cases where there are multiple values, they will look like key equals value one, um that thing value two. Sorry. As with most things in Linux, if there are spaces in the value, it needs to be contained in quotation marks. In Kali Linux, your environment is your bash shell. Each user, including root, has a default set of environment variables that determine how the system looks, acts, and feels. You can change the values for these variables to make your system work more efficiently. Tailor to your work environment to best meet your individual needs and potentially cover your tracks if you need to. Viewing and modifying environment variables. You can view all your default environment variables by entering env into your terminal from any directory. Okay, that's cool to know that you can, enter it from any directory, and like you don't have to go to like a specific directory to access it. So, um, wait, control was it control T terminal or is it control N? I forgot there is a shortcut for terminal for accessing terminal, but here we can, well, let's leave our top, um, and then Z, okay, but I want it to be Y. I forgot. Is it capital Z? Shoot. Oh no, that was capital C. Okay, it's capital C. All right. Well, let's create it. Let's add in another one. Terminal here. All right. Okay, so we can get into it by. Whoops. Oh my gosh, that's a lot. Less terminal. Oh, that's what I was doing. Was it? Oh, what I was setting up. All right, so get it from here. Envy, color, terminal, term, true color, language, blah 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 blah. Too much. Okay. Environment variables are always uppercase, as in home, path, shell. Okay, those are the variables. Okay, and so on. They are only the default environment variables that come on your system. Your user also created their own variables, and you will see we need a different commands to include those in the output. Viewing all variables, environment variables. Scroll. Okay, so to view all environment variables, including shell variables, local variables, and shell functions such as any user-defined variables and command aliases, use the set command. This command will list all environment variables unique to your system, which in most case will give you an output so long you won't be able to view it all on a single screen. You can request to view each variable line by line in a more accessible fashion using set and piping it to the more command as follow. Okay, so we use shell, well, not shell but set, and then we pipe. Okay, more, and then now here we'll be able to see more. Okay, less than, oof, my gosh, that's a lot. That's a lot. Look at that, look at that. All right, we can get out of this now. Too much. Hey, doesn't have an end. Now the list of variables will fill up the one screen, one line by line. Oh my gosh. Line by line. And then stop. When you press enter this terminal, advance to the next line, second. As you recall from chapter 2, okay. Q. I prefer using Control C. Filtering for particular variables. Although using set with more gives manageable result than looking through the huge chunk of variable names to get set alone, it is still rather tedious if you're looking for a particular variable. Instead, you can use filter grep to find your variable of interest. Let's use the variable hit size as an example. This variable contains the maximum number of commands your command history file will store. These commands are any ones you've previously typed into your command prompt in this session, and can be recalled with your up and down arrow keys. Note that hit size doesn't store the command themselves, just the number of them can be stored. Okay. Pop your side. All right, so we can do this set and then grab hit size. Was that it? Was it hit size or hist size? Not hist size. 1,000. Okay. For some reasons I wanna open hist size. Where is hist size? Hist size now. Okay, locate hist size. Where can I find it though? What hist size folder? I'm gonna try to find that so I can see my past commands and see if I've gotten better from using commands. Okay, as you can see, the container changing variable value for a session. Now let's see how to change a variable's value. As noted, the hist size variable contains the value of the number of comments to store in history file. Sometimes you won't want your comments perhaps because you don't want to leave any evidence of your activity on your own system or a target system. In that case, you can set the hist variable to 0 so the system won't store any past comments. No, I want to leave my comments back on. Yeah, hist size equals 0. I'm gonna leave mine on, but that's a good thing to know, especially when you're like doing forensic, digital forensic. That's good to know that you can access something like that. Now when you try to use the up down arrow to recall your commands, nothing happens because the system no longer stores them. This is stealthy, although it can be inconvenient. It is for me right now. It is like I do not need to close that out. I definitely do not need to close that out. Oof. Okay. Making variables values change permanent. So when you change an environment variable, that change only occurs in that particular environment. In this case, that environment is the bash shell session. This means that when you close the terminal, any changes you made are lost. With variables are set back to their default. If you want to make the changes permanent, you need to use the export command. This command will export the new value from your current environment, the bash shell, to any new folder child processes. This allows new processes to inherit the export variables. Now, my thing is, okay, we set, right? Can I edit that? Like, if I do nano set, like cat set, no, like it's like that, right? Can I edit any of these, like on any of these parts out? Oh, yeah. Yes, you can. Okay, so per, I guess perhaps, if I can say it, if I can say patch Rs. Well, saying it's not a command. Well, this one is it's not something that has like a value to it. So like something like this, like UID 1000, I could set it to 0. Like UID. Okay, let's do that, right? So we can do UID equals 0. Just failed to change the user ID operation not permitted. UID equals 0. Alright then, sudo UID equals 0. Okay, sudo UID equals 0. My gosh, it doesn't want to do it. All right, and then we do set. I don't know if he set it up though. Grep UID equals still 1000. Okay, it's still 1000. Echo. Oh, it's just me. Kali his side. Okay, so we can do stack his size. Okay. Okay, is that where it is? Like, his size 1000. How come cat? Well, okay. Cat 1000. No file or directory. Okay, echo is to print out. Okay, can I print out echo UID 1000? Okay. All right, so we can use echo to print out these things. Widgets. Can we? It's widget. Of course not. You can't print them out. Of course not. Okay. Let's see. Well, this looks like it's not a lot. Like I don't have a lot of changes applied. Okay, I guess that's good. You know, because I don't need all of those changes right now. Okay. Okay, filtering a particular variables. Sorry, I'm already past that. Okay, so now we export the new value from a current list allows the process to inherit the exported value. Variables are strings, so if you run on the cache size, it isn't a bad idea to save the content of a variable to a new text file before you modify it. For example, since we are about to change the PS1 variable, which controls the information you display in the prompt, first run the following command to save the existing values to a text file in current user's home directory. This way, you can always undo your changes. If you want to be even more cautious and create a text file with all the current settings, you can save the output of the set command to a new file with a command like this one: set send it that's home, oh sorry, home value of all blah, 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 that text. After you've changed a variable, as we did in listing 7.1, you can make the change permanent by entering export, then the name of the variable you changed as shown here. Export hist size. Now the hist size variable will still be set to 0 in these environments and will no longer store your command. If you want to reset the hist size variable to 1000, simply enter this: hist size equals 1000, exports hist size. Okay, all right, understood. This code snippets will set your hist size variables values to 1000 and export it to all your environments. Changing your shell prompts. Okay. Let me check something before that. Your shell prompt another environment variable provides you with useful information such as the users you're operating as and the directory in which you're currently working in. The default shell prompt in Kali takes the following format: okay. If you're working as the root user, this transfers to the following default. So username at hostname current directory. That's a lot. What's my current directory right now? Username at hostname. I forgot what my hostname was. But those, I believe it's pretty simple to you can just type in hostname and you see it. At least that's what you do on Windows. Let's see if that's the same thing here. You can change the name in the default shell prompt by screening the value of PS1 variables. The PS1 variables has sets of placeholders for information you want to display in the prompt, including the following: -u, the name of the current user; -h, the host name; -w, the base name of the current working directory. This is very useful if you happen to have shells on multiple systems or are logged on a multiple accounts. By using the -u and -h variables values, you can tell at a glance who you are and where your current system is. Okay. So I can have multiple shells open and all of them can be, I guess, logged into as a different person. Okay, I guess, well, for me, I'm trying to check into what would I be doing in order to do that. I guess if I'm trying to change files, like upload files, transfer files between users, that could be one way to where I have all of them opened. And if I need to find where some certain files are at, I go to this user's shell and I look at the files and look at the directory and then copy that to the other shell. Something like that. All of that. Okay, this is very useful. And now watch, him, the book, tell me exactly what I was trying to explain to you. Okay, this is useful, very useful if you happen to have shells on multiple systems or are logged on multiple users by using the. Okay, let's have a little fun and change the prompt in your environment. For example, you could enter the following: world's best hacker, world's best hacker. That was funny. All right, now every time you use this terminal, you'll be reminded that you are the world's best hacker. By any subsequent terminal you open will still have the default command prompt because the PS1 variable only holds values for your current terminal session. And remember, until you export a variable, it is a very good it is only good for that session. If you really like this new command prompt and want to continue to use it, you want to export it just like that. Export PS1. How about a little more fun? Say you really want your terminal to look like a Windows command prompt. I do not. In this case, you will change the prompt name to C and keep the W to the W, which W is for dash slash W, the best name of current working directory. Prompt to share current directory as not really. If I wanted to be like a Windows, I would be on Windows, my guy. That okay. Having your prompt show your current directory can generally be useful, particularly to a beginner, so it's something to consider when you change your PS1 variables. Yeah, I guess I could do that. Like for example, right? For example, when I open the like if I open the computer tomorrow or the VM tomorrow, right? I will be in desktop. Sometimes I will, of course, I will not know that, and I'll start putting in commands, and commands will not be working, and I'll be asking myself, "Are they not working?" But because I'm not in the correct directory. Changing your path. Sorry, guys. Today I'm just gonna read a lot. One of the most important variables in your environment is your path variable, which controls where you are, where on your system your shell will look for commands you enter, such as grep, ls, and echo. Most commands are located in the sbin or bin subdirectory, like user/local/sbin or user local/bin. If the bash shell doesn't find the command in one of the directories in your path variables, it will return the error command not found, even if the command does exist in your directory, not in your path. You can find out which directories are stored in your path variables by using echo in this content, like so. Okay, to search for the path. Okay. Just this assigns the original path variable plus the /root new hacking tool directory to the new path variable. So the variable contains everything it did before plus the new tool directory. If you examine the contents of the path variable again, you should see that this directory has been appended to the end of the path as shown here. Okay. Now you can execute the new hacking tool application from anywhere on your system rather than having to navigate to its directory. The bash shell will look in all directories listed for your new tool. Adding to path can be a useful technique for directories you use often, but be careful not to add too many directories to your path variable, because the system will have to search through each and every path directory find commands. Adding a lot of directories could slow down your terminal and your hacking. Okay, I was not gonna touch it, so I'm still not gonna touch it. How not to add path variable. One mistake commonly made by new Linux users is assigning a new directory, such as hacking directly to path variables this way. Path equals, can't do that. I wasn't gonna try. Okay, if you use this command, your path variable will only contain the root new hacking directory and no longer contain the system binaries directories such as /bin/spin and others that hold critical commands. When you go when you then go to use any of the system commands, you'll receive an error command not found as shown text. Unless you are first navigate unless you first navigate to the system binaries directory when you execute the command. Remember that you want to append the path variable, not replace it. If you're in doubt, save the contents of the variable somewhere before you modify it. Creating a user-defined variable. You can create your own custom variable. You can create a custom variable, user-defined variables in Linux by simply assigning a new value to a new value that you name. This may be useful when you are doing some more advanced shell scripting, or you find you're often using a long command that you get tired of typing over and over. The syntax is as straightforward. Enter the name of your variable, followed by the assignment symbol, goes without a space, and then the value to put in the variables as shown here. Ali hacking is also, oh, that's too long. This assigns a string to the variable, my new variable. Just like our system environment variable, user-defined variables must be exported to persist to new sessions. If you want to delete new variables or any variable, use unset command. Always think before deleting a system variable, though, because your system will probably operate much differently afterwards. As you can see, when you enter the new of your variable, you delete the variables along. Oh. You might find environment variables foreign, but it's worth getting to know them. They control our environments. Alright. Okay. Today I will only be able to do these ones. Chapter 7. I know we didn't do much of the exercises, but that's all of chapter 7. It wasn't a long one. It's just something to consider, something to kind of like to customize your Linux environment, to customize your experience, because if you're in a good experience, then you'll be in a good feeling to do some more of the hackings and things, all the other cool things. But it's also cool just to do that, change your things. That's cool. That could be a way to, like, I mean, if you're able to hack into like a system, and if you want these people to have a hard time tracking you're doing, you change everything. You change variables, you add new variables, you change how everything look, to just, it could also be a little prank. You could go and prank somebody else on their Linux, and then you change everything how they look, and just see how. That's a devious plan, though. That's a devious plan, but yeah, it's good. It's, if you trying to hide your activities on a certain computer that you hacked into, so you're not found, you do that. All right, and now next we're going to be reading chapter 8, which is bash scripting. All right. I mean, I think this should be my favorite one. It's one where I will really need to be focused. As a matter of fact, other than chapter 7, I wish chapter 7 was chapter 6, and then chapter 6 was chapter 7, because I think that would have been great. Like, I wish chapter 7 was probably like much earlier in the chapters, like, because the chapters before that, they were a lot more technical, if you know what I mean. Like, they were a lot more technical, and then chapter 7, it just changes everything and just calms you down. But yeah, I think like before the permissions, yeah, definitely before the chapter 5, it should have been chapter 4. And after that, you just, once you start getting into like the the technical and stuff, then you just go in. But I like that but I also don't think that it's a bad thing that it was a chapter 7. It was for chapter 7 because that kind of like calms you down, just takes you back to the fun, because after doing too much, if the previous chapters were kind of like of a headache or too much for you, chapter 7 is easier to just calm you down. But yeah, guys, that's chapter 7. And this was more or less of a live stream, but more of like a video. But yeah, I hope y'all liked it. Sub, like, share, and all those other good things that YouTube wants you to be doing. So yeah, I'm gonna see you on the next one. Peace out, y'all. Have a good day. Night.